Okay, find the formula for a function f that satisfies the following conditions. We want to find the limit as x is approaching plus or minus infinity of f of x, which is equal to 0. So what they're saying here is that is there a function that approaches infinity, negative infinity and positive infinity when the function is equal to 0? Well, one of those functions that we can look at is the reciprocal function. And that reciprocal function is 1 over x. So let's just verify that result on Desmos. Okay, if we put in 1 and then divide that by x, okay, we can see that as x is approaching positive infinity here, it's approaching 0. And as x is approaching negative infinity, it's approaching 0. So we know that 1 over x represents this first scenario. Okay, now we want to take a look at this scenario where it says the limit as x is approaching 0 of f of x, which is equal to negative infinity. So when we look at this function, we can look at something similar in the first one, but it would be 1 over x squared. So let's see what happens when we graph 1 over x squared. So 1 divided by x squared. Okay, now it says as x is approaching 0, right, we want this function to approach negative infinity. So currently right now it's approaching positive infinity. So what can we do to flip this? Well, we can use the rule of rotating it according to the x-axis by multiplying this function at the beginning by a negative. So if we multiply that by a negative, now this function is now approaching negative infinity when x is approaching 0. So we're going to put a negative in front of that. Okay, now we have f of 2, which is equal to 0. So what does that tell us? Well, that tells us that there is an x-intercept at 2, 0, which means there is a factor in the numerator that would be x minus 2. So we know that this would have to go in the numerator because of what's given here, which is an x-intercept. So the next scenario, we have the limit as x is approaching 3 from the left of f of x, which is equal to infinity, and the limit as x approaches 3 from the right of f of x is equal to negative infinity. We can see that these limits do not equal each other. So since they do not equal each other, that means that there's discontinuity at x equals 3, which means that there is a vertical asymptote at x is equal to 3. So that means we can have 1 over x minus 3 as fulfilling this particular requirement here. Now let's go ahead and graph that and see what that looks like. So if we put 1 and divide that by x minus 3, we can see that here, as the limit as x is approaching 3 from the left, okay, it should be approaching positive infinity. And as the limit is approaching 3 from the right, it should be approaching negative infinity. So if we want to flip this by rotating it around the x-axis, then that means we would add a negative to that. So now we can see that as x is approaching 3 from the left, now it's going to positive infinity. And as it is approaching 3 from the right, now it's going to negative infinity to satisfy that particular requirement. So what can we say about this function? Well, we know that it's going to be a negative, and we know that the numerator has to have a factor of x minus 2 because that is an x-intercept. And we know that it has to have an x squared in the denominator, and also a vertical asymptote at x minus 3. So therefore, there is our function. And now if we wanted to, we can distribute the negative sign to get 2 minus x in the numerator over x squared times x minus 3.